Okay, trying this again since last time it had no audio. So now I get to start all over. Yay. Okay, so this is a video about the different force types that you need to know. And there are 4 of them. All right, so the first one let's talk about is the force of gravity. Oops. All right. This is a force we're going to label F sub g for the force of gravity. And it means the same thing as your weight. So in a problem statement, it may say, for example, that something weighs 400 newtons. If it says that, that's the one you're going to plug in for Fg. All right, so on a person, the force of gravity is interaction between the person and, we're going to say the Earth, because it's almost always the Earth. Might be the moon, something else, but almost always is the Earth. All right, so on my force diagram of the person is feeling a downward force of gravity. The thing in the circle is your feeler. So we need to look for forces of what is being done to this person. Not what they're doing, what's being done to them. So downward is the force from gravity is pulling the feeler person by the dealer Earth. All right. And when it's a force of gravity, it's always going to be a G here and an E here because the Earth is the only guy that's going to provide it. All right. Unless it was the moon, but I don't even think we're going to bother with it. Okay. So the Fg is force of gravity. This is who's feeling it. It's the same guy as this, right? Because this guy's the feeler. The Earth is always dealing it. All right. It's an interaction between the person and the Earth. So in a problem statement, it will tell you the guy weighs 400 newtons. The girl weighs 350 newtons. That is going to only be the force of gravity. Some of you guys on the quiz were trying to plug this in as some other random force, okay? The only one the weight is going to be is the force of gravity, always. So the other sneaky thing is that you can be given the mass. So let's say that the mass is 20 kilograms. So if you remember from the lab, force of gravity is equal to mass times little g, all right? And little g is the Earth's gravitational field strength, which is 10 newtons per kilogram, which means that for every 1 kilogram a person has in mass, the Earth pulls with 10 newtons. So a 20 kilogram person, if the mass is 20 kilograms times the field strength of 10 newtons per kilogram, this person is going to have a weight or a force of gravity of 200 newtons, okay? The only time you're ever going to multiply by 10 is the mass, all right? Again, in the quiz, some of you were trying to multiply, like if you were given like 450 newtons, you were trying to multiply this by 10 for some reason, okay? No, only the mass because you're trying to change it into newtons because this is a force diagram. It has to all be forces which are measured in newtons, all right? So just be careful. The weight always acts downward, force of gravity, Fg, the dealer is always the Earth. Okay, all right. Okay, now the other 2 that people got confused a lot were tension and normal. All right, tension is anything that is pulling. Normal, we're going to call anything that is pushing, all right? So some of you seem to have trouble figuring out whether it was pushing or pulling, okay? So here's some examples, all right? So the one on the quiz had, like, you know, somebody hanging. Whoops, he has 2 sets of arms. That's not good, okay? All right, so the one on the quiz had somebody hanging, all right? So there's going to be an interaction between the trapeze and the person. Okay, so they're either pulling each other or pushing each other. All right, so if you were hanging physically, you got to think about it. If you physically were hanging from a bar, would you be pulling down on the bar or would you be pushing up on the bar? All right, that's the only choice. Okay, and hopefully if you actually think about it, you'd realize you have to pull down on the bar. Okay, so the bar is being pulled down by you. So in turn, it is pulling up on you. All right, so that would be a pulling force. Anything that's like a hanging would be a pulling. All right, something else that would be a pull, right, is maybe something's connected by a rope or a tow truck or, you know, a wagon, something like this, right? So let's say that these guys are moving in this direction. Going to be pulling or pushing the wagon if they're going to the right. Well, he's going to have to be pulling it, right? You just have to think about it. So he's pulling the wagon, so the wagon's pulling him. So this is also a tension force. Okay? These are the main kind of things I think that will be pulling. I'm trying to think of anything else, right? Any kind of like, you know, cars connected, or like, you know, maybe there's like a, oh, how can I draw this? Like a tow truck, right? Anything that's pulling. You just have to physically think about the situation and see if they're pulling. And if one guy's pulling, they're both pulling. One can't pull, one pushes. If one guy's pulling, the other guy's pulling him. It has to be the same type, okay? A normal force would be pushing, okay? So the most obvious one is what we always have is the normal force from the surface. So let's say box, ground. We'll call this box, right? So the ground or any kind of a surface pushes perpendicular to the surface, okay? The other things that can push, right, is we've had a lot of these, you know, like guy pushes on the box, right? So you just have to think about it. Is he pushing this box or pulling this box? Let's say they're going this way. You know, of course he's pushing it. So if he's pushing the box is pushing him. Everybody's pushing. So these are all normal forces, okay? We've had a lot of these, you know, like the dude pushing the shopping cart, or like the mom pushing the stroller, right? Any of this kind of stuff. If it's pushing, they're both pushing. Everybody's pushing. All right, so you got to kind of just think about it and just think realistically what it would be. Okay? All right, and then the last one that is the most confusing one is friction. So the force of friction is a force where two surfaces are rubbing together. All right? So friction, all right, is going to be two surfaces rubbing together. So that's FF, feeler, okay? The dealer is always the floor or the ground or the table or whatever the surface is, because friction is always an interaction with the surface, right? It's like the toothbrushes. That rubbing together of the surface causes the friction. And friction's really complicated and hard to understand. So the suggestion is that you add it last, once you get a chance to think about everything else that's happening, okay? So let's look at a situation of a guy pushing a box, right? Yay, surprise. I mean, how many things can I make up? All right, guy pushing the box. So we have the box and the floor, the box and the person and the floor, okay? And then each of them are interacting with the earth. So hard to draw with this tablet, okay? All right, so these are all the things that are happening, all right? So let's just look at the box. And also my suggestion is to draw the force diagram in the order that you see it, right? So I would draw the person over here and the box over here. I think that will help, all right? So the first thing is they each are gonna have a weight. We already know that. So that's a force of gravity on the box from the earth, because always the earth, okay? The person will have his own weight too, force of gravity on the person from the earth. All right, so the earth is pulling both of them downward. Okay, in turn, since he's not moving up and down, the floor has to push up. So the normal force is a push on the box, from the floor. Okay, and there's a normal force on the person from the floor. Right? Okay, now let's look at the interaction between them, all right? The box is the feeler. So what is the box feeling from the person? Okay, the box, see the person here, he's pushing this way on the box. So the box feels a push this way. So that's a normal force because it's a push on the box from the person, all right? And in the problem statement, it would have to tell you something about the motion. Right now, all we know is constant speed motion or not moving. That's all we've got so far, but the other stuff's coming like, you know, Monday, okay? So get on it, all right? if you see constant speed or not moving, that means that the forces have to be balanced. That means on each side, they have to balance out. So on this picture, right, I know that the man is pushing the box this way. If there were no friction, this is like the bowling ball. Tap, 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 right? It's going to get faster. So there has to be like somebody tapping the opposite direction, which is going to be the friction. Because the friction always opposes the motion at the surface, okay, which is a little confusing. All right, so backwards, we have to have the force of friction on the box from the floor, right? Because the surface is always the one that's providing the friction force. Okay, and I know the friction has to be there because the forces have to be balanced and there's nothing else touching. There's nobody else it could be. It has to be the friction. Okay, now if we take a look at the person now, okay, the person is also feeling a force from the box because he's touching the box. So if the person is pushing the box to the right, the box has to be pushing the person to the left. And that's my feeler-dealer pair. That's my Newton's third law pair. So there's a push on the person from the box. And it has to be this way. So on the quiz, what happened, a lot of you put both of the forces to the right. Okay, then they're not a pair. They have to be opposite. Okay, and how would this box, if you just think about it, right? A lot of you did this, right? You made, you made this way person box, right? So you're saying the box is pushing the person to the right. Look at this picture. How could this box be pushing the person to the right? First of all, if he was, he'd be pulling him. Okay, secondly, that's not even possible. All right, so you really have to think about what you're writing. Don't just write random things. Okay, so that's your pair now. All right, so if this person is also moving at a constant speed, we have to have a balancing force, and it has to be the friction because there's nothing else that's touching him. Okay, so why is it to the right? All right, so let's look at his feet, right? So if we take a look, like a close-up of the guy's feet. Wow, it's hard to draw with this pen, okay? As he's walking, right, his foot is pushing this way on the floor, right? So his foot pushes this way on the floor. So in turn from that, the floor pushes his foot this way. And this is the one I care about because his foot is the feeler, right? He's the feeler. So I don't care what he's doing. I care what's being done to him, which is pushing to the right from the floor. That's why this friction is to the right.